Welcome to Study Loop.
Okay, so in this problem, we have a tennis ball going over at a height y. We know that if it goes too fast, it will overshoot the edge of the court here. And if it goes too slow, it will hit before the edge of the court. So we want to find the velocity at which it just perfectly hits the edge of the court. So in order to do this, we can use the kinematic equations, specifically with a change in y is equal to 1/2 the acceleration in the y direction times t squared, and there's no initial velocity in the y direction, so this is the total change in y. This must be equal to the height to the ground, which is just this y here. Okay, so if I'm going to solve that, of course, we know that a and the y is equal to the acceleration due to gravity. So if I want to write this in terms of time, I can write that time is equal to 2y over g. Of course, this is all square rooted. This is the total time it will take to get from height y to the ground. But now we want that the total change in x should be equal to this distance d here. But of course, that's equal to the velocity in the x direction times the time traveled. Vx is just equal to this v. So this is v times t. But I already know what t is equal to. Right? I solved it before, so I can basically say that the velocity then has to be equal to d over t, which then, when I substitute the first part, to y over g, and that gives you that final answer. Now I can plug in values for d, so let d be 12 meters, let y be 1 meter, and we'll approximate g as 10 meters per second squared. Well, if I go ahead and write this all out, I get v is equal to 12.0 meters times, when I go ahead and solve this, I get something about √5 seconds. So I get 12 times √5 meters per second. And this is about equal to 26.8 meters per second, or again, as the problem suggests, 27 meters per second. Now it also asks you to determine, well, does the mass matter? But as you see in all these equations, mass never comes in. So provided that it's traveling at this velocity, doesn't matter what mass it is. But you'll get that the mass does not matter in this problem. And that concludes then this problem.